Hi, my name is Alex Waldrop, and today I wanted to talk to you a little bit about digging up dark data with a search tool that we've created called Doug. So, for today's talk, I'm going to be talking a little bit about what Doug is, why we created the tool, and just give you a short demo of its core functionality. You can see it there on the right. But what is Doug? Let's get right down to it. Um, as you can see from the screenshot on the right, Doug is a framework for semantic search over biological data that we developed as a tool for NHLBI's Biodata Catalyst project. The goal of the project of Biodata Catalyst is to provide a powerful automated tool portal for providing unified access to these publicly available genomics datasets. And so that's why we created Doug, to give users a smarter way to browse across the massive amounts of data available through the Biodata Catalyst portal. And just as a little background, for those of you wondering, the name Doug is a play on the name of the dog from the Disney film Up, as we envisioned Doug as a companion in the digging up of difficult data. So thought you all might enjoy that if you're Disney fans. So perhaps an even better question is, why is Doug? It doesn't even sound like a question, but it is. The short answer here is that biological data are messy and there are very few global standards in a lot of places. So dbGaP, or the database of genotypes and phenotypes, is a perfect example of this concept you can see in the middle there. dbGaP is a central NIH repository for genomics data sets and contains tens of thousands of publicly available data sets that together have measured 200,000 or more different experimental variables. That's great, right? What's the problem? The problem is that studies in dbGaP are allowed to name these variables whatever they want, which is great in terms of providing freedom, descriptive freedom, but not so great if you're trying to make a system that is searchable in a comprehensive way. So why is that? Why is that a problem? Let's illustrate the point. Let's pretend I'm a researcher interested in searching dbGaP for data sets about heart attacks. Now, in this contrived example here, we have 5 data sets that have all measured the same thing, whether or not a patient has had a heart attack, but they've called it 5 different things, right? Heart attack, myocardial infarction, cardiac arrest. And so each one of those is actually different, even though they're measuring the same thing. Now, this is a problem for text-based search. Because if we're to use a simple or even a more sophisticated text-based search like fuzzy search, we'd be lucky to find more than 2 of these, using some combination of either heart or cardiac. You're really never getting back more than 2 of these with one single text-based search. And that is the problem with text-based searches. They'll always fail to return the full set of relevant results when data are non-standardized as very common in large biomedical databases. So that brings up the point of, why is Doug? Doug is semantic aware. It was designed and built to be semantic aware, to know that all of these are the same thing. So that when I'm looking over dbGaP, I know that heart attack, myocardial infarction, cardiac arrest, heart episode, and cardiac episode are all ways to say heart attack. And that's what makes Doug so unique. In fact, there are 3 reasons we feel that Doug is so unique. For one, as we mentioned, Doug searches for results over biological data sets in a semantic aware fashion and returns things related to biological concepts, not necessarily textual strings that the user is searching for. For 2, because Doug uses a knowledge graph to create that semantic search capability, it's actually able to explain to you why it's returning certain search results. Finally, Doug is unique because it's a data structure agnostic framework. What the heck does that mean? Well, it means that Doug is equally able to, it means that Doug makes no assumptions about what the data looks like that it's going to be searching over. It's flexible enough to be used to search over databases like dbGaP, as well as image stores like the Google Diacom Images Library, or really anything with text-based biological metadata. That's what Doug is designed for, and to augment that with semantic terminology. So today, let's go ahead and do a little bit of a demo to just take a look and see what exactly Doug is showing. What you see in front of you is the main Doug search interface. Let's try a search. Let's actually try out our original example and look for data sets pertaining to, say, heart attack. Hit search. When the results come back, Doug presents you with a list of study variables that are pertinent to your search. As you can see here, we have myocardial infarction, resting heart rate from EKG, heart failure, so on and so forth. Immediately, as we can see Doug's semantic capabilities. The word heart or heart attack don't appear anywhere in the description of, for example, myocardial infarction. But Doug is smart enough to know that myocardial infarction is a biologically equivalent term to heart attack. Take a closer look at the results page. Now, what is Doug actually showing us? Doug is showing us that a lot of studies contained in the Biodata Catalyst uh, platform have recorded measurements pertaining to heart attack. You can see these are actual studies that exist in there that they have data for. You can look at the Jackson Heart Study or the Framingham Heart Study, for example. Drilling in at some of these results, Doug actually also presents us with a list of the individual variables measured in those studies so that we know how to find them in the platform. You click on the link, you can even get more information about that variable in particular, so myocardial infarction locator, and the data set itself. So if I wanted to click on Framingham Heart Study, I could. So the search interface of Doug is very useful and smart as well, in addition to the semantic search capability in its search field. Another thing you can look at is taking a look at these other results is that Doug presents a range of biologically semantically related terms that a researcher might be interested in. Now, this feature is particularly useful for biomedical data because there are often many synonyms for talking about the same thing. For instance, let's look for something like blood pressure. The first result that comes back is hypertension, which obviously textually looks nothing like the word blood pressure. Or you could also look at, say, a blood clot. That's another interesting one here because what it brings back is a quantitative indicator of venous thromboembolism status. That is a fancy way to say a blood clot. And that is kind of illustrating what Doug is meant to conquer in terms of the problem of biological data, that there are so many synonyms that textually may not look the same. So it's important to have a search engine that is biologically, semantically aware of the relationships between these terms to better search over the data sets that you're looking at. Now let's take a look at Doug's other critical feature. Doug can actually explain to you why it's bringing back the results that it does. For this, let's say we're interested in metabolic syndrome. Great. The first result it brings back here is triglycerides in blood, which seems on the surface a little bit maybe tangentially related, but Doug actually has a section here called Knowledge Graph, which if we click on it, will explain not only the links in the underlying knowledge graph of Doug as to why it's returning the search result, but we have actual links from PubMed literature supporting these links. So if I click on this link, it will actually take me to a published research article supporting the link between the search term here and the search result. So Doug is explaining to us why it's bringing back certain things and providing scientific literature to support those conclusions. That's actually what makes Doug so powerful, is that Doug provides a robust semantic search across biological data sets, which expands on what we would be finding using just text-based searching. But not only that, it's able to explain why it's returning the results that it does. And that's what makes Doug a truly unique search tool that can be used to dig up even the darkest and strangest data sets in the biomedical sphere. And the final takeaway here is that Doug helps us dig up biological data by actually better understanding the underlying biological concepts. And as the size of these biomedical data repositories grows, tools like Doug that are semantically aware and able to easily and flexibly search across really complex data collections are going to be increasingly important. So thanks for coming to our demo on Doug. We hope that soon it will help you dig up some of your dark data sets around biological data collections near you.